Yes. Hello, everyone. So today, now we are going to discuss a question based on crossing of river, and it's again a question based on Irodov. So just look at the board. Let's read the question. It says two swimmers leave point A on one bank of the river to reach the point B lying right across on the other bank. One of them crosses the river along the straight line AB, while the other swims at right angles to the stream and then walks the distance that he has been carried away by the stream to the point B. Okay, so two different cases. Then, what was the velocity u of his walking if both the swimmers reach the destination simultaneously? Okay, the stream velocity is given 2 kilometers per hour, and the velocity v dash of each of the swimmer with respect to water, obviously, that's given as 2.5 kilometers per hour. So let us first draw diagram for this case. Okay, so there is a river like this, and 2 points. The swimmers are starting their journey from point A, and the exactly opposite point is B. Both the swimmers' final destination is to reach that B. Okay, so it's better, I think, to draw two cases. Okay, so one case is the driver, sorry, the swimmer would be starting from point A and reaching exactly point B. That's what they're saying. What's the exact statement? They're saying that. Um, Two swimmers leave point A on one bank and reach the one of them crosses the river along the straight line AB. So one of them is crossing the river along the straight line AB. That is only possible if the swimmer starts like this. So this is the velocity of the swimmer with respect to the river. Swimmer 1, obviously, right? With respect to river. And then comes the river flow. So velocity of the river comes, and finally the velocity of the swimmer with respect to ground will become like this straight line. Okay, so what will be my equation for this? Can I say velocity of swimmer with respect to river is nothing but swimmer velocity with respect to ground plus river velocity with respect to ground? Sorry, plus alla, minus, it should be a minus. Now velocity of swimmer can be written as velocity of swimmer with respect to river plus velocity of the river. These are all vectors I am talking about. Okay, simple formula of vector, that is relative velocity concept. Now what is the velocity of the swimmer with respect to river? He is moving, let us say, at some angle theta, so I am getting it as velocity of SR, um, minus velocity of SR sine theta j cap and I cap, and plus VSR cos theta j cap, plus velocity of the river is always in the direction of VR I cap. That's it. So from here I am getting the relation as VR minus VSR sine theta I cap and plus VSR cos theta j cap. So this is a general relationship, right? Now, if the person or if that swimmer is going along the line AB, the conclusion is that my sine theta should be equal to VR divided by VSR. How I am getting that? If the swimmer has to go exactly along the line AB, that means it should not be having any x component of velocity. This direction, obviously, I am trying to mean it as x direction, and this direction I am trying to mean it as y direction. So my particle should not have any x component of velocity. So I just equated this to 0. From there I am getting sine theta equal to VR by VSR. Now VR value, velocity of river is given as 2 kilometers per hour, and velocity of the swimmer with respect to river is given as 2.5, that is 5 by 2. So I am getting it as 4 by 5 sine theta is coming out to be that. From there I am able to find out that theta value should be equals to how much? 53 degrees. This is what I'm getting. Okay, now why do I need this? Because in question they are asking to find out with what velocity should the other swimmer walk on the shore, on the bank, so that finally all of them would be meeting at this point at same time. So time is important. Now you tell me, with what velocity is the swimmer, with what, in what time is the swimmer crossing the bank? So time, if you require, then we can say time is nothing but distance by speed, right? What speed we are having? Let us say the width of the river is W, and with what speed is that man crossing, this swimmer crossing the river? So I can say the time comes out to be W divided by crossing of river is only done by which component? The J cap. So that will be basically VSR cos theta. So this is the time taken by the first swimmer to cross the river. Okay, so like shall I call it as T1, representing the time taken by the first swimmer? Okay, all right. Now let us talk about the second swimmer. Second swimmer's journey is more adventurous because the second swimmer started its journey from the same point A, but instead of going straight towards point B, what he did is he started swimming in the direction of AB. So he started like that. So this is actually his velocity of swimmer with respect to river, VSR direction. But now river will apply its velocity, right? So river's velocity comes in this direction, and then finally this is how the man is actually moving. Velocity of the man, or let us say velocity of the swimmer with respect to ground. So because of his velocity like this with respect to ground, the man, instead of reaching at B, is going and reaching at this point. Okay, so um, can we find out again this angle? Because if I can get this angle, then I'll be able to find out how much he has got drifted. I'll be able to find out, and if I can get that, I'll be able to find out the time taken for that, and based on that we'll be able to calculate. So before doing all that, first of all, this man is crossing the river by using which velocity? See, this man, the Vs is his actual velocity, right? So if you want me to write the vector of Vs, the vector Vs, how would it look like? Vs is basically addition of these two vectors. From vector addition, we can understand this vector, that is VSR plus VR, is equal to, the resultant is basically Vs. So can I say the vector Vs is nothing but VR I cap plus VSR j cap? This is actually the velocity. Now you tell me, from this velocity vector equation that I have written, which component of velocity is responsible for crossing the river? Obviously, it is the VSR that is responsible for crossing the river. So can I use that and say that time taken here, already I'm calling it as T1 here, so let me call it as T2. So T2, the time taken to cross the river, okay, by this swimmer, can be written as distance covered, that is a W, the same width, okay, divided by with what speed it is crossing. It is crossing with the speed of VSR, right? And how much is this VSR value? 2.5 in the question. So I can write it as 5 by 2. 2 will come up of 2W by 5. This is the time in which the man crossed the river. But the problem is, while crossing, the man did not reach the point B. Instead, the man reached from point A to point C. Here is the man after this much time. So according to question, the man has to come back to B. So the man will now travel on the bank with a velocity U. How much distance he will travel? So for that, let us call this as what? This is considered as the drift the man has had. The man had that drift because of the velocity of the river. I can find that drift by using this triangle. Look at this triangle. The bigger triangle with the side D and the smaller triangle with the side VR. By looking at that, we can say that these triangles are similar. The bigger triangle is similar to this smaller triangle. Both are having the angle here as 90, and therefore can I say that is VR divided by VSR is equals to D, the drift, divided by the W, the width. Okay, so using this I'll be able to say that my D is equals to VR, which is equal to 2 divided by 5 by 2 into W, so 4W by 5. This is my D. Okay, so already I got the time taken for the man to reach from A to C. Now I'm interested in this time, so now I can write that time T3 can be written as how much distance it has to cover, D, and with what speed it is going to cover, U. But how much is the D value? I already know that D is nothing but 4W by 5U. This is the time t3. That's it, last. This t2 plus t3 is basically the time taken for the man to go from A to C and then to B. And t1 is the time taken for this man, this swimmer, to go from A to B. As per question, this time should be what? Same. They should reach there simultaneously. So we can say t1 should be equals to t2 plus t3. What is t1? T1 is nothing but omega divided by VSR cos theta. Oh, I didn't find the value. Let us find it. So we can write it as W divided by VSR. The value for VSR is 5 by 2. And cos theta, how much is the theta value? 53. Upper cos of 53 would come out to be how much? 3 by 5. Correct. Cos of sine of 53 is 4 by 5. Yes. So 3 by 5. 5 gets cancelled. I'll be getting this value as 2 omega by 3. That is my T1. So I can substitute that. 2 omega by 3 is equals to T2, which is 2 omega by 5 and plus 4 omega by 5u. Not omega, sorry, it's the W is basically the thickness. I was assuming that, and you can see that assumption is anyway getting cancelled. I can also cancel the 2's. So what I have now is 1 by 3 minus 1 by 5 equals to 2 by 5u. So this will give me 5 minus 3, 2. 2 by 15 equals to 2 by 5u. 2 gets cancelled, 5, 3. And from there, finally, I'm getting u is equals to 3 kilometers per hour. Okay. So very nice question based on the crossing of river. With this question, we were able to cover both the cases, right? You may not have understood, but this is the case of what? Shortest path. So shortest path case also covered, and that one is basically shortest time. So this case also covered. So it's an Irodov question. I hope you have understood that. We first case we found out the time taken for the swimmer to reach from A to B directly, and second case it went from A to C and C to B. We found out the time for that, that is T2 and T3. And finally they are saying simultaneously they should reach, but that means the T1 for the first journey should be equals to the T2 plus T3 for the second part of the journey. So they should be equal, equated that, and you got the answer. Okay, so we'll be stopping here. Any doubts or confusions, make sure to comment and tell me. Okay, thank you.